right, so 3.1, part 2. We're going to be solving exponential equations. So one way that we can solve exponential equations is the one-to-one property, which just means that we want the bases to be the same. If the bases are the same, then we can set the exponents equal to each other. And then keep in mind when we're solving, anything raised to the power of 0 is 1. So if I had 100 raised to the power of 0, what would this be? 1. Or if I had 17 to the power of 0, what is this? 1. So anything to the power of 0 is just 1. Keep that in mind when solving. So let's look at A on the next page. So we want to solve using the one-to-one property, which means we want to get the bases to be the same. Is it possible for me to make 9 have the base of 3? Yeah. 3 to what power is 9? 3 to the second power. So notice here how I'm not changing the value of 9. 3 to the second power is still 9. They're the same value, they just look different. So be super careful when you're solving these questions. Don't change the value of something. So you can't make 3 squared on this side and change it to 9. It doesn't work that way. So just be careful. So then we have 3 to the power of x minus 2 equals 3 to the second power. Once our bases are the same, we can cancel them out and just set the exponents equal. So x minus 2 equals 2. From here, what would we do to solve? Add 2, so x equals 4. So that would be our answer. Let's do B. So what do you think our common base here would be? I could make them both have a base of 2. 2 to what power gives us 16? 2 to the 4th power would be 16. So notice how we're not changing the value, we're just changing the way that it looks. How could I change 1/2 to have a base of 2? 2 to what power gives us 1/2? -1. And then since we already have an exponent there, we just multiply it by the exponent that's already there. So 2 to the power of -1 gives us 1/2. A negative exponent makes it a fraction. Now that our bases are the same, we can cancel them out and set the exponents equal to each other. So negative x equals 4. Divide by -1, so x equals -4. Let's do C. So here I can't get the bases to be the same, but 6 to what power gives us 1? 6 to the power of 0, so x equals 0. Anything to the power of 0 equals 1. All right, next we're going to talk about the natural base E. So E is a button in our calculator. It's kind of like pi, where it's just a fixed number. E is about 2.718. It keeps going, but it's just a button in our calculator. So it's not a variable. You're not plugging in anything to E. It is just a button in the calculator. E to the power of x is called the natural exponential function. This page just talks about where E comes from. It's kind of the background. You guys don't need to know the backstory behind E. Just know that it is a button in your calculator. Example 7, we're going to practice using the button in our calculator. So it says use a calculator to evaluate the function e to the power of x at each value of x, round to 3 decimal places. So here we have e to the power of 4.2. Most calculators have an e raised to the power of x button. So you would click e to the power of x and then just put 4.2. So this should give you 66.6863. We look at the 4th decimal to tell us how to round to the 3rd. If our 4th decimal is 3, do we round up or keep it the same? Keep it the same. So our answer would just be 66.686. Let's do the same thing for B. So we're going to plug in 30. So I have 125 times e to the power of 0.05 times 30. Now you can put this all in the calculator at once, but just be careful. I like to do it step by step. So the first thing I would do is evaluate the exponent. So 0.05 times 30 would be 1.5. So I have e to the power of 1.5 times 125. Next thing I want to do is evaluate e to the power of 1.5. So I have e to the power of 1.5 should give us 4.48168. It keeps going, but I'm going to leave it in my calculator. It's going to be helpful. Leave every step in your calculator just so you keep as many decimal places as possible. The very last thing we want to do is multiply it by 125. So you should get 560.2111. Look at the fourth decimal place to tell us how to round to the third. If our fourth decimal is 1, do we round up or keep it the same? Keep it the same. So 560.211. So it's super important that you practice putting this into your calculator so you know how to use your calculator for the quiz. This is an exponential function. Would this have exponential growth or decay? Well, we look at our base, which is e. Is e greater than 1? Yeah, e we said was 2.7. So this would have exponential growth. But to graph this, plug in values for x. You can make your little chart, get your y values. So same thing we were doing yesterday. So next we're going to talk about compounding interest. So we have compounded interest versus continuous compounded interest. So after t years, so t is the amount of years, the balance A in the account with principal P and annual interest rate R in decimal form is given by the following formulas. So when it's compounded n times per year, we use the first formula here. P is going to be our starting amount. R is the rate, but in decimal form. So if it gave me 50%, what would the decimal version of 50% be? 0.5. Perfect. So you just move the decimal twice. If we had a rate of 3%, what's the decimal version of 3%? 0.03, perfect, or 0.03. So just move the decimal place twice to get the decimal version of your percent. N is the amount of times that it's compounded per year. So it'll give us some wording for n, and we have to figure out the number. So typically we might see that it's compounded daily. How many days are in a year? 365. So n would be 365 if it's compounded daily. What if it was compounded weekly? N would be 52. What if it was compounded monthly? N would be 12. What if it was compounded quarterly? N would be 4. So there's 4 quarters in a year. Semi-annually, N would be 2. Semi-annually happens twice a year. And then annually, N would be 1. These are the probably most frequent ones that you'll see. So you got to know these. So N is the amount of times that it is compounded per year. T is the amount of years. Now, if something's compounded continuously, so if it says continuously compounded or compounding continuously, it's got to have that word continuous in it. Then we use a different formula. We're going to use our A-PERT formula. So it's A is equal to P, which again is our starting amount, times E to the power of RT. E is just the button in our calculator. R is our rate again, and T is the amount of years. So if it says continuously compounded, we use the A-PERT formula. So on the next page, we're going to do A. It says find the accumulated value of an investment of $15,000 for 2 years at an interest rate of 3.2% if the money is compounded semi-annually. So let's find, with our formula, we have A is equal to P times 1 plus R over N to the power of N times T. So let's find everything for our equation here, our formula. What would P be? 15,000. It is our starting amount. So we're starting with $15,000. What's our rate? The decimal version of our percent. So we got to move it twice.
0.032.
Awesome, 0.032. And then what would N be if it's compounded semi-annually? N would be 2. And then how many years are we talking about? What's T? 2 years. So once we have everything, let's plug it into our formula. So A is equal to, P is 15,000 times 1 plus R is 0.032 over N, which is 2, to the power of N times T, so 2 times 2. Now just be careful when plugging this into the calculator. The order matters that you plug things in. I like to evaluate the exponent first. 2 times 2 would be 4. It's just going to save me a step when I do the parentheses next. Next, I'm going to do inside the parentheses. First thing I have to do in the parentheses, though, is going to be divided. So in my calculator, I have 0.032 divided by 2. And then plus 1, you should get 1.016. Then I'm going to raise that to the power of 4. So that should give you 1.06555. It keeps going, but I'm going to leave it in my calculator for the very last step. We're going to multiply it by 15,000 times 15,000. You should get 15,983.28 cents. The decimal would be 0.286. When we're talking about money, we round to 2 decimal places. Would the 6 tell us we round up or keep it the same? We round up. Anything more than 5 tells us that we round up. So we would want to round this up to 0.29. So when you're talking about money, it wants 2 decimal places. I don't think WebAssign tells you with these types of questions what to round it to. It just assumes that you know when you're talking about money, it wants 2 decimal places. So always round 2 decimal places with money. Any questions here? For B and C, they're the same. So we use the same formula. When it's compounded quarterly, what would our N be? N would be 4. When it's compounded monthly, what's our N? N would be 12. So just pay attention to the wording for your N. D is a little bit different because it's compounded continuously. If something's compounded continuously, we use our A per formula. A is equal to P times E to the power of RT. So we have the same P and R and T here. So let's plug that in. A is equal to 15,000 times E to the power of 0.032 times T, which is 2. So first thing I want to do is the exponent. In my calculator, I'm going to put 0.032 times 2. So we have E to the power of 0.064 times 15,000. But next I'm going to do the E to the power of 0.064. So that should give us 1.06609. It keeps going, but I'm going to leave it in the calculator for the last step. The last step I want to multiply by 15,000. So times 15,000 should give us 15,991. And then our decimal is 385. 5 tells us that we round up or keep it the same. We round up. 5 or more, we round up. So our decimal would be 0.39. So $15,991.39.